really quick section. This whole cycle has a lot of really quick sections from the book. This is another one. It's adding polynomials. So we're really focusing on like terms in this one, and identifying which like terms can be added together and which ones can't. So for this one, I'm just going to go through the first 3 problems with you, and then you have 4 to do on your own. Again, the first one's probably the longest one, just like in most of the sections in the book, and then the rest of them are a little bit easier. So complete the following table. When finding each sum, state the answer first using the given units, and then if possible, convert to a common unit or combine further. So for this expression, the first one, we have 2 centimeters plus 7 centimeters and 8 meters. So the objects being combined, we have centimeters first, and then we also have meters. I can't add centimeters with meters, but I can combine the 2 centimeters and the 7 centimeters to give me 9 centimeters. So I added, so I've got 9 centimeters plus 8 meters. They're not the same units, so I can't add them together. I will either need to convert the 9 centimeters to meters, and then I can add the meters, or I can convert the meters to centimeters and add the centimeters together. So if you add the meters together, so 0.09 meters plus 8 meters would give me 8.09 meters. And remember, if you're like, wait, how did she get that? There's 100 centimeters in a meter. So to go from centimeters to meters, I divided by 100. And to go from meters to centimeters, I multiplied by 100. And we did that in the last cycle with the converting units. I just kind of skipped over that a little bit and didn't show all of my work. Hopefully that wasn't like, whoa, way too fast, Miss Sanchez. Like, you gotta slow down. You can absolutely show your work if you need to on how to get those. It might be helpful for you. Otherwise, if you remember that it's multiplying and dividing by 100, that's all I really need. Then if I wanted to add the centimeters, it would just be the 9 centimeters plus 800 centimeters, and I would get 809 centimeters. So that was converting between the common units. You could have also just converted both of them to meters and then converted meters to centimeters. A couple different ways you could have gone about this problem. This is just the way that I chose to. The next one, we have 2/5 and 1/5. So what objects are being combined? It's these fractions that are being combined. More specifically, we're talking about fifths. 2/5, 1/5. 2 pieces of a pie plus 1 piece of a pie if the whole pie is cut into fifths. So that's my object being used. I know the last one was the units, and this one is more of like an object or pieces. I don't need to convert anything. I can just add the 2/5 plus the 1/5 because the denominators are the same. So I add the numerator. 2 plus 1 gives me 3, and then the denominator stays the same. The next one, 0.03 plus 0.05. The objects being combined, again, not really a unit specifically, but more of the placement of the number. Both of these are hundredths. So this is actually 300ths plus 500ths. Remember, decimals go tenths, hundredths, thousandths. So that is the objects being combined, is this hundredths. And then I can add them together and I get 0.08, which is how most of us, I think, say it. I don't want to make assumptions, but the actual way to say it is actually 8 hundredths. Next one, we have 5 quarters, 10 dimes, and 20 quarters. So the objects being combined, we have quarters, and we also have dimes. I can combine the quarters together, 5 quarters plus 20 quarters to get the 25 quarters, but I cannot combine the dimes into that. I can, so how do I really add these together? Well, I can add them by cents, like how much money I have. So 25 quarters would give me 625 cents, or $6.25, however you want to say that. And then 10 dimes would give me 100 cents, hopefully, or $1. Hopefully you know how to count money, and I don't need to explain that further. So then in this case, I can add the cents up, and I'd be left with 725 cents, or $7.25. I can also add up like the individual coins. If I was counting coins, 25 quarters and 10 dimes, I have 35 coins, or just the 725 cents. If you didn't get the coins part in the answer, that's totally fine. I felt like 35 coins was kind of a reach of like combining things together. But that's what the book said, so we'll go with it. The next one, we have 2/3 plus 5/3 plus 1/2. Very similar to the second one that we just did, with the fifths. So for this one, hopefully you can guess, we're combining thirds, and we're also combining halves. So I can combine the thirds together, the 2/3 plus the 7, or I just gave you the answer, plus the 5/3, and I get 7/3. I can't add in the 1/2 yet. I have to find a common denominator. The common denominator would be 6. So I converted both of those fractions into 6, and then I can add in the numerator and keep the denominator the same. And I'd have 17/6. Next one, hours and minutes. I absolutely hate hours and minutes. Combining them together, I'm horrible at it. Hate doing it. Our units being used here, objects being combined, we have hours and we have minutes. Hopefully that wasn't too bad. I can combine my hours together. 5 hours and 7 hours gives me 12 hours. And I can combine the minutes. 2 minutes plus 2 minutes plus 54 minutes gives me 56 minutes. Well, altogether I have 12 hours, 56 minutes. So I can either combine these together using minutes or hours. So I'm going to convert both of them. 12 hours, 12 times 60 is 720 minutes. Or I can convert minutes to hours. So I would go 56 divided by 60, part out of a whole, and I would get 0.93 hours, which makes sense because 60 minutes equals 1 hour. I'm just shy of 1 hour, so 0.93, little bit less than 1. That answer hopefully kind of makes sense, and you're like, oh, okay, I see how you did that. So I can either combine the minutes together and add the 720 plus the 56, and I'd get 776 minutes, or I can combine the hours, 12 hours plus 0.93 hours, and get 12.93 hours. Either way, however you like to think of time there. The next one, we have 0.05, or if we're actually saying it correctly, it's 500ths plus 4 thousandths plus 123 ten thousandths. I actually don't say decimals very often, but 0.0123. I can't combine any of those together. I have to add, remember, I have to line up the decimal. I can't just add 5 plus 4 plus 123. I have to line up the decimals correctly. So my units are hundredths, thousandths, and 10,000ths. And I would get 0.0663 is my final answer. So when are we able to add objects? When are we not able to add objects? We're able to add the objects when they have like objects or like terms. So if they have the same denominator, I can add them together. If they're the same kind of unit, I can add them together. I can add hours together. I can add minutes together, but I can't add hours to minutes since they're in different units. So when they're like objects, I can pretty much add them together. And then moving on, we have like terms, same variable raised to the same exponent. They do not need to have the same coefficients. So 3xy and 4xy are like terms. They have the same variables. The x and y are the variables. Coefficients are different, and that's fine. Now, if I had 4xy to the third and 4x to the third y, not the same. The exponents are different. Doesn't matter that the coefficients are the same, but the exponents are different. The first one, I have just one x, but 3 y's. And then in the second one, I have 3 x's and only 1 y. So those cannot be combined together. They have an example for you where they go through and they kind of circled and boxed the like terms and then color-coded it. So you could kind of follow along with how they did that. I just highlighted. I didn't color code them, but we're going to identify the like terms, and I highlighted, and then simplify the expression by combining those like terms. So a minus 9a, like terms, plus 23, not a like term. So I have negative 8a plus 23. And then in the next one, I have 8x squared plus 4y plus 8y plus 16x squared minus 12x. So I highlight the things that are similar. The 12x does not get combined with anything. It doesn't have any like terms. So I can combine those purple highlighteds with the yellow highlighted terms. And I get 24x squared plus 12y minus 12x. And then for the part C, I again highlighted my like terms. This time I have 3 w squareds that I can combine together, 2 w's, and the negative 1 cannot be combined with anything. There's my answer. Part D, this square root of x, that is the x, the square root is actually the exponent. It's to the power 1/2, if you didn't know that. So I can combine those together, and I get 8, the square root of x. The 3 plus the 5 is how I got the 8, and then the term with the exponent is the square root of x. E, again, I highlighted, and I combine the like terms. Part F, I highlighted and combine the like terms. Hopefully those were pretty straightforward, not too confusing. And then the last one that we're gonna do together, whoops, dropped my iPad. Okay, let me scroll back. Okay, the last one we're gonna do together is number 3 here. We learned about the exponent rules in section 2.3 for multiplication and division. This section explores the ideas of addition and subtraction of terms, some of which have exponents. So we're going to combine all the rules kind of together, not in very complicated ones, not very complicated expressions, kind of more basic expressions. So for this first one, 4x to the third times 4x to the third. So I multiply the coefficients, I multiply the two 4's together, and then I add the exponents. So I get 16x to the 6th. Next one, I have 4x cubed plus 4x cubed. And they're being added together, so all I can really do is just combine like terms and add the 4's together, and I get 8x to the third. I can't do anything with the exponents. There's nothing actually to do with the exponents because they're just like terms. They're not being multiplied together. The next one, I have 4x cubed times 4x. The x has an implied 1 as the exponent. So I'll go 4 times 4, multiply the coefficients, x, my variable, and then add the exponents, which is 3 plus 1, and I get 16x to the fourth. And then the last one, I have 4x to the third minus 4x. There's nothing I can do to this one. They have the same coefficients, but that doesn't matter to me when I'm subtracting. The variables are not the same. One is x cubed and one is simply x, so there's nothing I can do. I just rewrite the expression. Okay, so go ahead, go through the homework sections. I think I gave you 4 of them, 1, 2, 3, and 5, and email me if you have any questions.